world's best talking show. Today we are going to be doing a machine learning workshop, and no guests are needed. I am the one who will be teaching machine learning, and it's going to be a very good time. This is normally a talk that I give to a lot of hackathons, or a lot of prospective students, or a lot of people who are just kind of interested in machine learning in general as a concept. And as I go through talking about this concept, hopefully I'll have a lot of interaction. You guys can engage in the chat, and we can start learning about machine learning right now. It's going to be very, very exciting. So anyway, let's go ahead and get started. I believe we have students from the other CS class here. Is that right? Do me a favor and throw in the chat if you're here from the other CS class, because I'm really interested. I've actually went to the other CS class a few times just to check it out, just to see what's going on. I know what available is, but I did want to go over there and check out what was going on. It was actually really cool. I remember watching. I was thinking, like, man, I wish I had something like this when I was starting to learn how to code. And let's see here. Let me get the chat up. There I am. There's my face. Yeah, we all love seeing my face. Okay, we still are live. Good. Go that all the way live. Restream is super weird because, like, I'll be live and then, like, on Twitch I won't be live, but then I'll come back on. So let me just make sure I got that. And I have this, and I have the chat. I think I have it all set up. Oh, we get the chat over here. Okay. Yay. Hello, everyone. From Make School, right? I think. Why is this a chat replay? No. Okay, anyway, we are just going to go ahead and get started for the people, for the viewers that are watching. Anyway, let's go ahead and get into the show. So the first thing I'm going to do is I'm going to link this in the chat. If you're rewatching this, then it's all right. I'll find a way for you to get there. So we're not going to look at that screen. We're going to look at this screen over here. And here we go. Machine learning workshop, and I will put a link to the slides. You don't need a link. I'll put a link to a lot of other stuff. Yeah, I'll give you a link for this. All right. Anyway, let's go ahead and get started. So quick draw emoji. So today, to explore the concepts of machine learning, we're going to be looking at a quick draw emoji machine learning tutorial. And what we want our machine learning model to do is to be able to tell when we've handwritten an emoji. We want to be able to know what emoji that is. And this is a problem of image kind of classification or image recognition, which is a very common problem in machine learning. Hello, first slide about the workshop. Anyway, so I'm going to help you do a few things here. We're going to do it together, but I'm going to help you do a few things. And the first thing is we're going to identify examples of machine learning in daily life, learn 4 core concepts. There's only 4 of machine learning, and then we're going to train our own interactive machine learning model and explore some of the code, play and experiment to better understand how the machine learning model learns over time, and discuss the impact of machine learning on our world and how you can help shape it. I read it just in case you couldn't read it. So now we're all on the same page, and you can go ahead and help me by in the chat. If you're from CS class especially, go ahead and put in the chat just how familiar you are already with machine learning. 1 to 5, 1 being like, I don't know anything about machine learning. I've seen the words before, but I don't know anything about it. And 5 being like, not only do I know about it, I've been able to implement my own models, and I've solved problems using machine learning, yada, yada, yada. And if that's the case, then still hang out would be a good time. But I would suspect most people probably around a 1 or a 2, and that's completely all right. And at the end of this, you're going to be at a firm 3. That's for sure. Not only will you know what machine learning is, but you'll know what the code looks like. You'll be able to mess with it some. And let me know if I'm going too fast or too slow, etc., etc. Help your peers and your funds. If you're spotting typos, let me know. All right, let's go ahead and type them. So we are talking about machine learning, and when we talk about machine learning, we're really talking about 4 different things. There's only 4 things in all of machine learning. It could all be sort of boiled down to this. And these 4 things are: 1, data collection, data formatting, model training, and then prediction making. We have those 4 key things that we need to do. Again, let's do it again. Data collection. If you think nothing else from this, take away these 4 things. Data collection. Or data. I'm not sure. Data formatting. Model training. Prediction making. Data collection. We collect the data. Then we have to format the data. And then we train our model with the data. And then we make same time about the audio. Okay, hold on one sec. Let me try and shift it over. To take me for a Let me go to restream. In other words, I'm just going to take out the headphones. All right. How's that sound? Does that sound a little bit better? Let me go ahead and X-nay these things. Take me for a ride. To take me for a ride. It's better now? Okay, so did everyone miss the entire beginning? Okay, here we go. Can you troubleshoot before proceeding? Audio is awful. Okay. All right. Are we good now? Word. All right. Let's start from the exact beginning. And let's just keep going. And let me make sure I'm still live. I'm still live. And just like with machine learning, we take in some data and then we make some iterations and we change it up a bit. And then that's what we have to do. So anyway, let's go ahead and start from the very beginning, from the very top. Hello, everyone, and welcome to Tech Topical, Tech's Best Talking Show. I am your host, Brian Ross. And today we're going to go through a machine learning workshop. It's better the second time. And as we go through this, you're going to be learning about the core key concepts of machine learning. And that's kind of the goal of today. I've given this talk before, of course. I've given it to hackathons, to prospective students, to high schoolers, and everyone seems to have a good time. So hopefully you have a good time too. Anyway, let's go ahead and get rocking and rolling and pick up where we left off. So here's our slides. Oh, before we even get started, I mean, we are live on Twitch, but go ahead and let me know in the chat. If you are from the CS class, go ahead and let me know if you're from the CS class. I've actually been to a few. You probably missed the story. I've been to a few already just to go check it out. I wanted to see what was going on. And I got to tell you, it looked like a good time to me. I wish I had something like that when I was learning to code, like a cool Twitch stream thing going on. I don't know. It looked good. The instructors looked like a good time. And after you've put, if you're from the CS class, put a 0. Well, start at 1. Start the index at 1 for this time. Put like a 1 to 5, 1 being, just how familiar you are with machine learning. So 1 is like, I don't even know what's going on. I don't even know what machine learning is, in which case you're in the right place. 5 being, not only do I know what machine learning is, I could give this talk, and I've implemented my own models, and I make a lot of money as machine learning data engineer. Don't you dare say. So if you're a 5, then put a 5. But at the end of this, you're all going to be around a solid 2, maybe even a 3 if you go a little bit crazy, meaning that you know what machine learning is. You can tell me what it does. You've implemented your own code before. We've even started to distinguish some of the different types of models. I don't think we'll get that far. You're definitely going to be at a 2, though. That's for sure. Let me see what's going on here. All right. Now that we are hydrated, let's go ahead and dive in. Where were we? You can still see the screen, right? No, you can't. Okay, let me go ahead and share that. And bam. Let's go. Okay, here we go. About the workshop. Isn't that so cool how that just popped up like that? Yay, restream. Okay. Quick draw emoji. So today, what we're really trying to do is we have hand-drawn emojis, and we want to be able to recognize what these emojis are so that if you draw them, I can make a prediction about what that is. And this is sort of the problem of image classification or image recognition. And we've seen this type of thing before when it comes to, I don't know, what's a famous example? Image recognition with machine learning. I guess Tesla. With the autopilot and driving around, they use a lot of machine learning to try and identify what the different stuff that they should not hit is. And that's a pretty important thing. And machine learning models for recognizing, maybe stars in deep space or asteroids that are coming near us. We want our machine learning models to be able to make predictions, take in a bunch of data, and do it faster than humans can. Otherwise, what's the point, right? So next slide. Hello. About the workshop, et cetera, et cetera. All right, so anyway, there's 4 key concepts that you need to know with machine learning, and just 4. 1, 2, 3, 4. And if you know these 4 things, and you know
pretty much everything there is to know about machine learning, at least on the conceptual level. You'll be able to look at anything and you'll be able to categorize it in your mind. What are the 4 different things that are going on? And then you can go talk to your friends, and anytime machine learning pops up in the conversation, which I'm sure it does all the time, you can talk educated about it, and you can be the smart person in the room, and you can tell your parents, it's a machine learning model, and really there's these 4 steps going on, and there's data collection, and so we'll be able to learn all of that. It's going to be a good time. And last time I read it with the messed up mic, but we're just going to have fun with this. We're going to have fun with it, identify the 4 core concepts. We're going to look at some models. We're going to have some fun. Anyway, I already asked you these questions. Go ahead and put that in the chat. 1.25, my boy, Hube, my dog, you are in the right place. All right, during the workshop, let me know if I'm going too fast or too slow, etc., etc. I'm not worried about anything on time. I have all the time in the world. You do too, I assume. Anyway, let's dive right in. So what are these 4 steps that I alluded to with machine learning? Well, first, number 1, we have data collection. Number 1, collecting the data. Very, very important. Then we have the data formatting. So once we get our data, we need to format it so the computer can understand what's going on. And then we go to the model training. And that's when we train the model. The machine learning model starts learning and learning and learning. And after it's learned quite enough, it doesn't have to learn that much before it starts making predictions. And then that's kind of what we want to see. Are the predictions accurate? Are they useful? And can we use this for something? Because unless we can use these predictions for something, then there's really no point doing any of this. That's the whole point. That's where the money is made. The good prediction making. And that's the hard part. So we have data collection. Again, if there's only one thing you take away from this talk, it's these 4 things. So activate your memory part of your brain, and remember data collection. Brian Ross from Make School said, remember data collection, data formatting, model training, and then prediction making. Those 4 things we are going to be looking at, and we're going to be having a good time. And if you want to follow along with what it is that's about to be going down, I'm going to throw this link in the chat. And here we go. Bang. And that's going to be a document. That's right, a good old Google Doc. And it's going to look something like this. And you can see that, right? Yeah, you can see that. So it looks something a little bit like this. And we have a whole bunch of links. We have a whole bunch of blue hyperlinks that go to stuff. So you can just go absolutely crazy. But I want you to do, dear listener, is go to, you see where it says Workshop Challenge Options Code Customization? Go ahead and click that one. And we're just going to zoom right on over. Zoom. And you're going to look, it's going to look like something like this. And first thing you're probably going to want to do is like log in to Replit. That's just something that they make you do, I think. Or maybe they stop it. Go ahead and log into Replit. If you don't have an account, then you have to make an account. And it's not that long, but it's just something you got to do if you want to go ahead and follow along. And then normally, I'm going to go ahead and just fork it right now. Let's try and all work on the same thing. Sometimes it doesn't work, but I'm going to put a link to this thing and we can all work together on it. At least that's the idea of Replit. Last time I gave this talk to Rowan and it just froze immediately. But let's try the same thing again and see if something different happens. Okay, bing. Okay, so that Replit takes you to the same one that I'm going to be working on, and we're going to be looking at machine learning through this. And let's see here. What happens if we just go ahead and click run? All right, go ahead and click run because we have to install all these different libraries and dependencies. I always forget about installing. And while that's installing, let's see here. What other slides do we have? So I've sent you the link. Oh, and also in this resource document, I'll go over it again. In this resource document, so this code customization thing, it fully works right out of the bag. So right out of the box, you just open it and then it works and it's great. And then if you want to get really crazy, there's another one called code activation. And this, it works, but sections of code are commented out. The CS students know about comments, very important, but it's all commented out. So you just remove the thing that makes it a comment and then it works. So you can like turn on different pieces of code, and that's pretty cool. And if you want to go really crazy, there's the code DIY, which is you start with the minimum amount of code and copy paste new sections into the code. And this is sort of like a big tutorial that's on Make School, or at least it should be. And there's a whole tutorial that you can walk through and see what's going on. Let me see if I can find where this tutorial is. The good stuff. If not, no big deal. I find it at the end, or someone in the chat will know where it's at. And nope. Okay. Access the full demo tutorial. Is this it? Hold on, this might be it. Bang, here it is. Found it. Yay, I'm the best. So this one is a whole tutorial I'm going to put in the chat. You can walk through and build this whole thing from scratch. Throw it in your portfolio. Bang, there it is. Yeah, that's a whole tutorial. Like bookmark it so that after this you can go over there and play with it, and then then you'll be the machine learning friend in your friend group. And let's keep going. Where are my slides? I'm lost without my slides. So we've already installed the libraries. We've installed everything. We're good to go. And yep. This is what it should look like. So you'll see this console down here. Go ahead and just make that nice and small. Okay. Quick draw emoji. And what I need you to do is hit this one. You see how it says app here on the left? You click app, and then you go down to model.py, P-Y. So you go to model.py, and we see some code here. That's pretty exciting. I'm already scared. No, don't be scared. We'll figure it out. So first thing we should do, I'm going to get rid of Jordan's name. Boo, Jordan. Put Brian there instead. And there we go. Okay. And actually what I'm going to do just right off the bat is, you remember how we comments? I talked about comments. It's these hashtags. Go ahead and get rid of this hashtag right here. Oh, there we go. Okay. There. Okay. Should be all right. I'm going to comment this one out because we don't really need it, but I will leave it there. I don't want to get crazy now. I'm going to stop it, rerun it, and then refresh. Beautiful. Okay. So quick draw emoji. So here's what we got going on. Ready? Here's what we got going on. So I'm going to draw this. Yay, happy face. And we submit. Nice. I'm going to draw another happy face. Nice happy face there. And as we see, as I'm drawing this, the machine learning model is making a prediction. It's saying, hey, you're drawing a happy face. I'm like, you're right. I am drawing a happy face. And you can actually all help me by drawing some emojis with me. I think I put the right link in the chat there. And then I'll put another one. Yay, another happy face. And as we see, the more happy faces we make, the more this training data happy face 3 times. So we have three happy faces in our training data right here. So what happens next? What if I want to draw, can you recognize my rainbow? All right, there's a line. There's another line. Oh, no, our prediction is wrong. You can see it thinks it's a happy face. Does this look like any happy face you've ever seen? No. It looks like a rainbow, though. You agree. So we'll put another rainbow in. Replit needs your permission to enable notifications. No, you don't. No notifications. Then I'll draw another rainbow. And nope, it still thinks it's a happy face. Let's put another rainbow. So how many rainbows do we need before you start realizing that I'm drawing you a rainbow? It's a very nice looking rainbow. Another happy face. Let's put another one in. And then, and then, and then one more line. No, not happy face. It's a rainbow. You fool. You machine learning model. You'll never learn. You'll never figure it out. Okay, another one. I didn't even guess that time. Oh, yay. Now it's thinking it's a rainbow. Now it's predicting this arc thing. It's like, hey, whenever you go with this crazy arc thing, that's a rainbow. So I needed to put a couple of rainbows in there before it started to realize, all right, what about a star? Let's draw the world's worst. No, not a rainbow. Let's draw a star. There we go. That's a star. All right, let's try it again. And then, and then, Now, how come this thing doesn't know that I'm drawing a star immediately? Well, oh man, look how terrible that is. Well, I guess stars can look like however they want. Really, a star just looks like this. I'm going to submit that as training data too. Any circle. Okay. Just mess up our training. Okay. There. If I can get this thing to recognize a star, I'm actually going to be really happy. Hold on. I'm actually really invested in this now. Okay. Star. Can I do it? Yes. Yes, it's doing it. It thinks it's a star. Yes. Oh, now it thinks it's a happy face. We were so close. What happened? All right, let's try it again. Star. No, not a rainbow. You're doing good. You can do it. Guess it's a star. It kind of looks like more like I don't blame it. It doesn't look like a star to me either, but regardless, that's what I'm trying. I'm trying machine learning model. And you can see it took us a while to put the rainbow in. Yes, we got it. Yes, we got the star. Yes. So it takes about like eight or nine different things to put in there, and then it starts to recognize. So what's happening here? Let's go back to our slides. What is happening here? One may be wondering. Well, I'm going to tell you. So remember, we had our 4 steps before, right? We had data collection, we had data formatting, model training, and prediction making. So this is the very first step that we're working on right here. This is called data collection, meaning that we are collecting the data that we want to do some training on. And the data, of course, is us drawing the emojis. And you can see, because every time we draw an emoji, we get this counter that's updated. And that training data, there it is. We're giving it some data. So that's the first step. That wasn't that hard. We can get data in other contexts. It might look like something else, but regardless, the thing is the same. We need data. And then next, we have to do our data formatting. Well, what does the data formatting part look like? Well, that's what the code is. Data formatting is what you get paid the big bucks for. So you go ahead and like all the training features, training labels, tree.decision, tree classifier, which means it's a classifier. And you go, save sample, delete samples, load training data. We go through all this crazy stuff and all that flatten list, update training. If you go through the tutorial, you learn about more like what each of these things do. We don't have time to dive real deep into it today, but you can, and I'd be happy to hang out with you afterwards and then take a look at it. And then we have this predict right here. This is making the prediction. So the data formatting is the part where you're actually coding. That's what that's all about. And we just want to format the data to make it so that these emojis that we're drawing, as we can see as we start drawing, where is it? Yeah. So the more we draw, you can kind of see these are like pixels. These are like pixels here on the screen. And that's how we're formatting the data. We're saying here's some pixels. And when these pixels are activated, that means it's this sort of emoji. And the more training data you give it, these are terrible smiley faces. The more training data you give it, the better it's going to be at making those sorts of predictions. Let's go ahead and get this. Once you start, you just can't stop. It's just such a good time. Let's see here, bang. Okay, now we've got the laughing face. This one's easy for it to recognize. It knows all about laughing. Machine learning models love to have fun, just like Cyndi Lauper said. Anyway, I think that's how the song went. So we have our laces. So anyway, we have those 4 steps. Now we've gone through. We're kind of looking at. We're getting a sense of what that is. What was that 4th step again? Let's see. We had no look. Ready? We had data collection. We had data formatting, and then we had model training. Okay. So what is model training in this circumstance? Well, the model training is us telling it whether it's right or wrong. So when I draw this happy face, this laughing face, bang, there it is. It thinks this. And then when I give it a little face, the training part is me saying that it's wrong. Bang. And that's why, have you ever used those CAPTCHA things? The answer is yes. And if you've ever used a CAPTCHA, and it'll be like, what's the one I just did? It was like, find all the bicycles in the photo. And they've gotten so sophisticated. Like now I don't even know where all the bicycles are. Like I'll find one bicycle, that one's easy. And I'll be like, bang, bang, bang. And I'll hit submit. And then it'll like, all the pictures go away and then a new one refreshes. And I'm like, okay, I guess I didn't get it. So I do it again, bang, bang, bang. And then I submit it and then it goes away. And then it's like, you failed to CAPTCHA. And I'm like, what? And it turns out there was like a bike like in the way background in one of the photos. I'm not supposed to be able to find that. But regardless, what you were doing and what the early CAPTCHAs were it was model training, essentially. It was us grading it was us sort of tagging the information with what the correct information is. So humans are looking at and saying, there's a bicycle here. Like 10 different humans all agree, bicycle in this image. So that way, when you give that image to the machine learning model and then you ask it, you're like, what's in this picture? Is there a bicycle in this picture? And the machine learning model will be like, no bicycle. And it'd be like, wrong. And it'd be like, here's the same picture again. What do you think? It'll be like, no bicycle. Like, wrong. Try again. Here's the picture. And you do that like millions and millions of times. And then the computer is able to look at it and be like, oh, that picture, I've seen that before. That's a bicycle. Because if you look at these pixels, those are bicycle pixels. So now I'm able to know. And now we're able to do that sort of thing. Let's see here. Enjoying the show. Yay. Make school bot. Data is messy, though. Great job creating realistic data set. That's right, realistic data set, because in real life, our data is not always so clean and perfect. And in fact, in real life, if we were going to do this emoji thing on some sort of some drawn images, some hand-drawn images, it might look something like this. Great segue, Brian. Yay. So let's make this big screen here, just so you can really tell. I don't want to hit present, then it gets all big. All right. Can I double click? No. Should I delete things on the slide without? Okay. Let's hit present. Now it's big. Okay. So as we can see here with this is like a real life data set, right? If we were trying to predict like what a dog is, and we had a drawing that looked like this, that looks like a dog. But if we got everyone in the room to draw pictures of the dog, including me, you would start getting images like this down here. These 3 eggs. This one next to the 3 eggs, which is like clearly a horse. And then this one, which is like a balloon animal dog, and then the one above it, which is more like what is that, like a hippo? But anyway, these are all people's best attempts to draw a dog. And as long as we don't give it information about hippos or horses, it's going to tell us that this is a dog as opposed to a carrot, even though these carrots aren't exactly photorealistic either, although they're a lot better. We have like a cartoon carrot over here with the crown. Looks like something being like Adventure Time or any other cartoon. This one looks like a pizza. But they all have the same sort of shape, and so the emoji, or not the emoji, but the machine learning model would take in all this data, and then it should be able to differentiate because they are pretty similar looking. The apples, this one has a bite taken out of it, and this is what real life training looks like, real life data looks like. It's always messy. You always have to, format it, and the machine learning model has to, it takes a little bit of time for it to recognize what exactly is going on. And the more images you have, the more data you have, ideally, the better your machine learning model will be, because it has more data to draw from. It has more examples of what's right. It has more examples of what's wrong. And therefore, it's able to make a prediction off of that. So if I know all the things that aren't bicycles, then I can more easily tell you what a bicycle is, especially if you tell me what it is and you tell me what a bicycle is not. I'll be pretty good at finding bicycles. At least that's the idea behind it. It does get a little messy, and there's a few interesting stories we can share. But this is kind of, so how does it do that? You may be asking. Well, you can kind of think of it as like a decision tree or a flow chart, right? So we start at the top here. Should I read this whole thing? All right, I'm going to read it really fast, even though I don't normally do that with slides, just because I feel like reading. All right. In general, decision trees are constructed via an algorithmic approach that identifies ways to split a data set based on different conditions. This is one of the most widely used and practical methods for supervised learning. Hacker tutorial. Did you get that? Basically, what it's saying is we have a decision tree. So, if we were trying to recognize an animal, like, does it have feathers? Yes. Okay. Can it fly? No. No. Okay, so it's a penguin. So it's looking at these different features of the data. Does it have this thing? Does it have X? Does it have like this thing I'm looking for? Yes or no? It does. Okay. Since it has that, now does it have this thing? And then no, it doesn't have that, but definitely has this. Okay, 1, 2. So therefore, it has to be a penguin. That's what the machine learning model is doing every time it looks at a new image. So when I draw another emoji, yay, more emojis. So when I draw this, it's like, okay, this has got to be a happy face, because we have this line, and that's a happy face, right? And I draw another line, and it's like, okay, it's definitely still a happy face. What about another line? Okay, it's laughing, easy, and I tell it's wrong, and then I do it again. I say, here it comes. There's a line. There's another line. Oh, now it's learning because it sees that's not a happy face at all. That's a rainbow. And now when I make this next line, because rainbows always have 3 lines that go that way in real life, I guess, and you hit submit, and then that's what's going on here. Now it's learning, and now it's giving us a prediction that we want it to. And the more data we have, the more we kind of would not run into these situations where we are drawing the same thing over and over. Maybe I can fix it to make it look really like a rainbow. What if I draw a 4th line? No, it still thinks it's a star. There's a rainbow. Okay, one more rainbow. Just so I can be happy. Oh, there it is, rainbow. Yay. Okay. Where was I? Got distracted. Yeah. So as it's going through that decision tree, it's like, does it have this pixel activated? Yes or no? No. Okay. Does it have this pixel activated? Yes. Okay. Therefore, it is a rainbow. So that's kind of what's going on here with the decision trees. Getting started. We did get started. Oh yeah, we've already gotten the Replit. You can access the full tutorial. Yay. And CAPTCHAs. I was just talking about CAPTCHAs. You remember. And yeah, that's a big. Oh wait, CAPTCHAs is a part of machine learning, but that's just part of also signing into Replit. That's why the slide is here. And of course, you can fork it. We've done all this already. Yada yada yada. Play and discussion. Okay, now we've gotten to my favorite part of. My bad, George. Now we've gotten to my favorite part of the machine learning talk. And every time I've given this talk to rooms of hundreds and hundreds of people, I always ask. I don't know if I've gotten to hundreds and hundreds. I've gotten, yeah, I think so. Why not? Every time I've asked this question, I've said, who's seen the Mar.io video before? And every time I ask that question, there's a substantial number of people in the room who have not seen it. And if you have not seen it, then today is going to be a very special day for you. It's going to be a special day for me because I get to be the one who shows you this video. And this is very famous in the machine learning world. We're going to watch it. And then afterwards, we're going to go through and we're going to look at, all right, what was step one? And step one, again, was data collection, shocking the audience. Data collection was the first step. So what's going to be the data collection step? And then what's the code formatting step? We probably won't know. And then, well, yeah, no, we will. And then three, what was the model training and then the prediction making. So we want to be able to identify all four of those steps in this Mar.io video. At least that's the goal. And if not, we can just watch it and enjoy the show and have a good time. So let's go ahead and watch this. Now, I guarantee you when I share this, the audio is not going to work. And that's going to be okay. I'll just reshare. It's never stopped me before.
Welcome back.
I'm going to pause. And let's see here. How should I do this? Here's what I'm going to do. Ready? Here's what I'm going to do. I'm going to be on the fly guy. I can minimize that. I'm going to go here. New window. Bang. Oh, this is going to be sick. And then I'm going to go to Restream. Oh, I'm so smart. I can already tell. I'm going to go to Restream. And then I'm going to go and add a new stop the screen share. And we're going to reshare. A Chrome tab. And we're going to share the audio. And let me see here. Which window is it? It's gotta be. Well. Where is it? Let's go ahead and just watch on YouTube.
Fred Smith here told us the B&H
No, not an ad. How do I have an ad right now? All the money I pay for YouTube Premium? Okay.
I was a fitness instructor.
Skip ads. All right.
Welcome.
Now we got it going. You can't see it yet until I do this thing. So I hit boom, and then I hit share audio, and then I hit share. And cool. Put that bad boy on. And yeah, good. All right. Now I'm going to make a full screen. We're going to watch it. If you can't hear it or if it's like too quiet or something, just put that in the chat, and then I will fix it. I guarantee it. Okay, here we go. Bang. I hope this works. And off we go. Enjoy. Tell me what you think.
Back, Sethling here. You're watching a skilled player play Super Mario World. But this player is not human. It's a computer program I wrote called Mar.io. This program started out knowing absolutely nothing about Super Mario World or Super Nintendo's. In fact, it didn't even know that...
It's echoey? Mute myself. Okay.
that pressing right on the controller would make the player go towards the end. Welcome back, Sethling here. You're watching a skilled player play Super Mario World. But this player is not human. It's a computer program I wrote called Mar.io. This program started out knowing absolutely nothing about Super Mario World or Super Nintendo's. In fact, it didn't even know that pressing right on the controller would make the player go towards the end of the level. It learned all of these things through a process called neuroevolution. In this video, I want to teach you about how Mar.io learned to beat this level, Donut Plains 1, what its brain looks like, and how it's all based on actual biological evolution. So let's start out by actually looking at Mar.io's brain. Let's play it again, but this time we'll look at Mar.io's brain as it's making the decisions of what buttons to press. It's going to look a bit complicated at first, but don't worry, I'll help break it down for you. This structure of colored lines and blinking boxes is called a neural network. It's a simple mathematical model for how a brain works, but it can produce some very complicated behavior. With enough computational power, a neural network could come close to simulating a real human brain, but modern technology isn't there yet. On the left side you have the inputs. This is what Mario sees. It's a simplified view of the level. The white squares stand for blocks the player can stand on, and the black squares stand for moving objects like enemies or mushrooms. On the right side you have the outputs. These are the 8 buttons that Mario is able to press by using its neural network. In between the inputs and the outputs, all those lines and boxes, those are the neural network. Each free-floating box is called a neuron, and the lines connecting those boxes are like the axons and dendrites in a human brain. At any given time, only some of these neurons and connections are actually being used, and this is what people talk about when they say you only use 10% of your brain. The neural network you're seeing is a pretty complicated one, and it got so complicated as a result of a 24-hour evolutionary learning session. So, to explain how neural networks work, let's rewind about 24 hours and look at how the whole process started. This is what Mario looked like at the beginning of its training session, all the way back in generation number 0. The program is probably even dumber than you thought at this point. Often it just stands there and doesn't even press any buttons. If Mario stands still for too long, it'll cut off a simulation and try the next neural network, so it's mostly just jumping from one simulation to the next. But occasionally, the neural network says to press the right button, and the player starts walking right. The behavior isn't complicated, but it's enough to make at least some progress in the level. Let's take a look at a sample neural network to understand just how that works. This is one of the randomly generated neural networks that appeared in the first generation of the simulation. There are some green lines and a red line, and one neuron in the middle. Here's how it works. A green line is a positive connection, and a red line is a negative connection. A green line reading from a black or white square will turn its output the same color. A red line reading from a black or white square will turn its output the opposite color. In this case, the green lines read from the platform that the player is standing on and make the neural network press the right button as long as the player is standing on it. However, when the red line reads a black square representing one of those caped Koopas, it presses the A button and makes the player jump. This puts the player in a position where the green lines are no longer reading a white square, so the right button turns off and Mario just stands there. This is a really basic example that illustrates how a more complicated neural network might operate. The more lines and neurons you have, the more nuanced the decisions can be. So, how exactly do we get those more complicated neural networks? The answer is evolution. When Mario gets further right on the screen, its fitness goes up. In this case, fitness is a function of how far right it gets and how quickly it gets there. Only the neural networks that produce the highest fitness are selected to be bred, creating the next generation. It took 34 generations of genetic breeding and fitness evaluation before Mario was able to finish the level without dying and get a fitness score above 4,000. You can see there were several places it got stuck for a few generations, but it always evolved out of those ruts. Let's take a look at a few of those ruts. You can look at the top left corner of the screen to see what generation number each rut occurred on. This process of picking the fittest individuals from each generation, breeding them together, and adding random mutations very closely matches the actual process of biological evolution that took single-celled organisms and produced intelligent humans. That's the power of neuroevolution. And though we don't yet have enough computational resources to produce something on the level of the human brain this way, it's kind of neat to see what it can do on one of my favorite games. I didn't come up with this idea on my own. This algorithm is called NEAT, which stands for Neuroevolution of Augmenting Topologies, and it's based on a paper by Kenneth Stanley and Risto Mikulainen. It's a really great paper that describes how to use genetic algorithms to build up neural networks from bare bones without presupposing the best structure for the neurons and their connections. It also includes some really cool ideas for separating genomes into species, which a lot of genetic algorithms don't really try and do. I wrote Mario from scratch in Lua as a plugin for an emulator called BizHawk. As I close out the video, let's take a look at the fittest neural network in each generation. It's kind of cool how sometimes you can see them make modifications to each other and improve performance, but sometimes an entirely new species becomes prominent and dominates the others. If you'd like to do more reading about the concepts I talked about in this video, I provided some links in the video description. I had a lot of fun working on this project and I learned a ton. Hopefully you learned something too. That's about it.
Whoa, that was crazy and really cool. Yay. So that's Mar.io. So now you can say that you've seen it when all your friends ask, have you seen Mar.io? And the answer will be yes, you have seen it. So that's kind of, at least I think, one of the best examples of what machine learning looks like in a practical sense, because we always see commercials about it, or we hear people talking about machine learning and how it changes the world. But that, I think this is probably the best example of something that you can see of how it improves over time. So what were the different things that were going on there? So remember, we had four different things we were supposed to remember. Brian said remember 4 different things. What were those 4 things again? He told me, and then I immediately forgot. Those 4 things were, 1, I think it was data collection, right? Because we have to collect the data. Okay, so we have data collection first. What would data collection be in this instance? Can you tell me in the chat what data collection would be? Let me see here. Data collection would be probably, well, let me see here. So what's the data that we want to collect? Well, I guess the data that we want to collect is data about the game itself. So probably giving you a chance in the chat. Let's see, any smart chatters? I know that there's a lag on the stream. There's a delay. Is it the points or the score of the attempt? That's a great question. Yeah, so in this case, you could think of the data collection as being sort of like the game itself, right? Because every single time we go through and we die, we want to take that data, we want to learn from it, and then the next time we go through, we want to have that data from the past to influence our decisions in the future. So every iteration we go through, all the information, like there's a lot of data being collected here. So we have data about the game itself, we have data about the Koopas, we have data about the mushrooms, we have data about obstacles in the walls. So we have to take in all that data, and we also need data about our past attempts, because our past attempts are going to influence what we do in the future, and it's going to like evolve over time. And what does the evolution look like? Well, it's kind of like, you see all those lines that are pointing to the squares? You see all those? If I point at my screen, can you see it on your screen? But if you see all the lines going to the square, yeah, you can see it on there. I can see it on my phone, so you should be able to see it. So if you look at all those lines, it's like every time we go through a new generation or a new species or whatever, we have a bunch of more lines that are just sort of like randomly assigned to different squares. And the more that happens, eventually over enough iterations, one of them is going to work out, and one of them might actually be pretty good. Now, what happens if you take this and you put them on a whole different stage? Is probably going to be not so good, because this is all new data and we haven't trained on the new data yet. And machine learning models, at least this type of machine learning model, is not good at extrapolating from incomplete or missing information, yada yada. Yeah, the goal is to avoid death. So the better it does at avoiding death, the happier it is. And of course, as humans, we also want to see it get to the end, because I guess you could avoid death by just standing there and jumping every so often. So we want to avoid death, and we want to get as far to the right of the screen as possible, because that's where the goal is, to the right. So that's sort of like the data collection. The data formatting, what would the data formatting be? Bonus points if you can sort of guess at what the data formatting would be. Do you know the answer to the question? I probably shouldn't do that. I know the Jeopardy thing is like heavily copywritten or whatever. But anyway, so the data formatting, that was a Jeopardy theme song, in case you couldn't tell. So it wasn't, I mean, just kidding, it wasn't the Jeopardy theme song. It was an original remix by me. Not a remix, just a complete original. No copyright at all. But the data formatting in this case, he alluded to it with the NEAT thing, the neuroevolution, augmented topologies, whatever that acronym was. That would be sort of like the data formatting part of it. So we're taking on all this data, we're going to use our code to put it into a machine readable format, and then with our machine readable format, we're going to move on to step 3. And step 3, of course, is the model training. And the model training really is like that fitness thing. Like that's when we're really doing the model training. And because every time it dies, we're saying that was wrong. You did a bad job, do it better. And then it does it better, and it still dies, and we're like, no, still terrible, do it again. And then it will eventually, over time, start getting better and better. And we train the model saying this brain connections that you got going on, wasn't working. Let's try something, do something completely different. Whatever you did, just don't do it the exact same way. Let's do it completely different, and then let's train. And then luckily, because we're on a computer, you can like speed up the whole process too. So you don't have to sit there and wait for it to do every single. Maybe you did. No, I don't think you did. You don't have to sit there and watch Mario just stand there before the game decides, like, okay, never mind, let's try a new generation. So computers make that process a lot easier. And, you know, really one of the things that got me into machine learning was watching chess engines sort of get better and better, which is really interesting. I wish we had more time. I would show you one of my favorite ever chess games. For everyone loves chess, right? It was on PogChamps. It's one of the most streamed games on Twitch. You know, broke records. People like chess, I'm sure. Anyway, so that's Mario. So now what I'm going to do is we're going to get rid of this. We're going to X-nay that. And I want to show you something else, because maybe some of you aren't gamers, but you like different types of games, like me, and you like soccer, because soccer's cool. And so what would this look like for a more you know, like in real life sort of live and in color sort of application? What would that look like? And I'm going to show you. This video is a lot shorter, and if you like soccer, you'll like this one. So let's go ahead and share that. So here, share screen, a Chrome tab, and then football analytics using deep learning. Cool. Now this one you haven't seen before, unless you've seen my talk before, because this one only has 26,000 views, and probably most of them are me. The Mario one had like millions of views. So this is what you pay the big bucks to see. So anyway, let's go ahead and watch this video. I don't even think there's any sound, but oh wait. Let me actually share the screen so you can see it. All right. And here we go. Football analytics using deep learning. And let me know if you can see this. Very cool. So as you can see here, what's going on, 3 different technologies, and as the game is playing, we have a few things going on. So we're mapping the human body movement on the top right. On the bottom left, we have a top-down view of the field, so we have the positions of all the different players. And then on the right is our prediction making. Let me make it full screen, so it's not like a video for ants. And so those are 3 things. And of course, at the top left, we have the raw video footage that we humans like to watch. So let's go ahead and watch it again. Better the second time. And the shot saved by the keeper. Cool. Body pose estimation, player's position, body direction, semantic level predictions of scenes. So here's more in depth. It's crazy to watch on the right side. I mean, the left side's cool, but the right side. And that body pose estimation is crazy. Who needs to look at the ball? And then, of course, we have the semantic levels predictions of scenes. And remember when we talked about it earlier, I said you had to remember 4 things. And those 4 things were what? It was 1, data collection. Okay. 2, data formatting. 3, model training. And then 4 was prediction making, which is what we just watched. Okay. So that's, how to become a football data scientist. You want to sit here and watch this hour and 30-minute video with me? Okay, maybe next time. Anyway, let's go back. I want to take another look at this. So let's go ahead and look at this again with our four key things. How much code does it take to do the machine learning? It doesn't take that much. I mean, I guess it's all relative, because for me, when I was learning to code, a lot of code was any code. But to implement any sort of machine learning, it doesn't take that much code. In fact, I'll show you something really simple, even simpler than machine learning workshop. And this is something I did in class. So this will be kind of cool. Class at Make School. You've heard of Make School. Football analytics using deep learning. So we have, okay, our first thing, of course, is data collection. So data collection in this instance has to mean, well, we have the raw video footage, of course. And then, but we also need, hold on. Did you notice this about the figures? Look at these stick figures. Oh, let me go back again. I want the, oh, there it is. Look at these stick figures. Do you notice how every single like part of the body is a different color? Not only are there lines, but like we have this yellowish line that goes to orange, then we have this green line that kind of turns to yellow, and then we have this blue side that kind of turns to, I don't know, less blue, and then this like greenish side. So what's that about? Well, that's allowing the computer to be able to distinguish the different parts of the human body, something that we humans understand intuitively. The machine has to be taught manually. So it's getting in information about all the different parts of the human body, and that's sort of the data collection. And then not only that, but we're also getting the positions of the other people as well. And as you can tell, the ball is not in here at all. We're not even looking at the ball. We don't even really need to, because we can make predictions based off of just the human body position. And as he's coming down, so we had data formatting. Data formatting, we'd have to look at the GitHub. We don't really know too much about the code or whatever. We can kind of guess that it has to do with image recognition. So something that like kind of like what we're doing. So image classifier. Should I go really crazy and make a guess at what type of machine learning model it is? Like an RNN or is it an RNN? It could be an RNN. It really depends. It could be a few different models. I'm not really sure. I'm going to guess RNN. Why not? Or should it be, or is it an LSTM? You'll have to watch. Hold on. Ready? Watch this. You'll have to watch the previous versions of Topical to learn about different machine learning models, and then maybe you can make a guess that's better than mine. But I'm going to guess, I don't know. I'm going to guess RNN because it has to be fast. So I'm going to guess RNN. So you can watch, of course, the past Topicals, watch Topical archives. So yeah, we had our data collection, data formatting, model training. And model training is actually really arduous in this instance, to use a college word. And arduous because a human would have had to sit here and tell the computer, all right, here comes a cross, here comes a combination charge, whatever that is. Here comes some Gengen pressing for you Football Manager fans, and we're going to do it for both the sides. So someone has to sit there and watch this game and manually tag, just like we had to do with our emoji, right? We had to draw our emojis and then tell the computer what emoji it was. And we had to keep doing that over and over until eventually the computer was like, oh, I've seen this pattern before. You're going to be doing a happy face. In this instance, I've seen this combination before. The goalkeeper is going to take a long kick. That's my prediction. And you can see it's fluid. And as we go, the predictions kind of, you have to make these judgments pretty fast, which is why I think it's an RNN. And I think that's a pretty cool thing there, because we started thinking about not only is machine learning a fun tool that people like me can get workshops on, but it's something that actually has a real use case in real life. Because if I was able to take in this information, soccer is a little bit challenging because it's so fluid. But football, if I was able to tell what your play is before you've ran it, I would imagine that gives me some sort of an advantage. If I have this capability and you don't even know I have it, then forget about it. I'm going to look like a super genius because I can predict everything you're going to do before you do it. That's quite the advantage. In soccer, before the game, how should we line up? Well, we've run our models and we think this formation is going to be the best. And that's actually a big debate right now in the sports world, is do we do it the old school way, or should we start implementing these new technologies? And how is there a way to blend the two? And it's all very interesting, all very exciting. The only thing I do know is if you dive into machine learning and you get really good at it, then someone will pay you a lot of money to figure out those types of questions. And hey, there's worse things to do for a lot of money. So anyway, those are two examples of what machine learning looks like in real life. And now you can play with your model. When you have a model, you can talk about your model because you know the four things, right? If someone puts in the chat what the four things are, that would be really cool. Because then I know I've taught something. Like, I've talked for an hour. It'd be cool to know that someone has left with something. The four things. What were they again? Imagine I forgot. No, I remember. Do you remember? Okay. See here. Playing discussion. Is it easy or hard to train a model to tell the happy face and the laughing face apart? Yeah, no, that's a good question. What about the rainbow and the star face? Did we have a star face? I'm glad we don't have a star face, because to sit there and then draw everyone saw my stars. I'd have to draw 2 of them for every image. That would take a while. But anyway, yeah. So these are good sorts of questions. Is it easy or hard to train a model to tell the happy face and a laughing face apart? And what it's kind of, because we don't have a lot of time, what it's kind of getting at is, oh, the video ended. Okay, hold on. I'll just go back to me. You're not even looking at the slides right now. Okay, let me get rid of this. Thank you. And let's see here. Where did that go? To take me for a ride, my sugar. Okay, here we are. All right, I'm back. Yeah, so really interesting stuff here. Really interesting to see just kind of like how it looks in real life. And is it easy or hard to train the happy face and a laughing face apart? Well, it can be kind of difficult because they look pretty similar, and the variances and the differences between what those look like can be minute. Not when I draw them, though, because I don't draw the actual outline of the circle. Maybe I should have, but let me see here. Let me go ahead and share screen again and make sure I've covered everything that we need to cover so that I send you out into the world and you feel like happy and healthy data science people, baby data scientists. Let me see here. Let's open up my Slack for everyone to see and let's find where Restream went. Okay, here it is. And share screen, Chrome tab, and bang, that one, share. Okay. So easy or hard, we talked about that. Let's see here, happy face. And then there's a few more questions here, of course, if we had more time. And then here's the typo. I saw the typo. And let's see here, more samples by more people. Yeah, so there's different factors that contribute to the increased accuracy of the model. We sort of talked about a lot of this. And so you're probably wondering, all right, I'm a machine learning expert now. What is next? Well, next, what you can do, first thing you can do is hit follow and for the Twitch channel that you're watching right now. Yay, Make School. Hit the follow button and subscribe and do all that sort of stuff. That'd be really cool. And then everyone can, of course, if you don't want to do that, or if you want to do that and do something else, you can join our Discord. And I'm going to put the links in the on the screen right here, right now. You can go ahead and join the Discord. And if you go through that machine learning tutorial that I shared earlier, that would be pretty cool. If you want to get to that tutorial again, this is the link to the tutorial, make.sc/laces. So you can go there, you can find the tutorial. When you start doing the tutorial and you get into you start having some issues, go ahead and join the Discord. And when you join the Discord, I'll be there. Other people from Make School will be there to help you out, either with the concepts or with the code itself, and start going crazy with it. And if you had such a good time watching Tech Topical, you could watch all the past episodes right there of the past live streams, including Aaliyah's show, which was right before mine. This is for the actual Tech Topical shows. Watch TT, make.sc/watch TT. That's right. They gave me my own Make School address, which is kind of cool. And then if you have such a good time that you're like, I want to learn more about Make School and I want to do it all, I want to be in there with everyone, then you can go to make.sc/apply. You can come hang out with me and everyone else who goes to school at Make School, and you can learn all these. Oh, that's right, I forgot. I wanted to show you something that we did in class. This will be the last thing, and this is, by the way, brand new, has never been shared before in any of my talks. You will be the first ones to see it as soon as I can find out where I did it, which was in a Google Collab Notebook, I'm pretty sure. So if I go to my Google Drive, I can just find it right away. Did you all enjoy that little workshop, little machine learning workshop? You got you know, you're leaving with something. You got some code that you can mess with. You got your 4 things. You watched some videos. You hung out. I would say that if you watched this and you didn't know much about machine learning, that you've had a productive hour because you've learned about machine learning. What'd you do on your Friday night? Well, or Saturday? Is it Saturday? Yeah. So well, I'll tell you what I did. Okay, Collab Notebooks. It's probably in my other email. Does anyone else have that problem where you have a million, you don't know which email address is the right one? Is it hypothesis testing? No, I don't think so. Copy of K nearest neighbors. Ah, that might be it. That might be it. I know you're not seeing anything yet, but you're going to see it. I'm going to do everything possible so that you can see it. Okay, cool. Yeah. Is this the one I actually did work on? Let me make sure. Okay. If this is a copy, then what the heck did I actually do the work on then? Or maybe it's better for you to show you so that you don't have the answers. What should I do here? Well, I want to show you the one with the working code. That's why I'm stuck right now. Let me switch over to my other email account. That's probably what has it. Takes 2 seconds. And Collab Notebooks. If you don't know what a Google Collab Notebook is, it's actually pretty cool. It allows you to run like some data science stuff and data visualization stuff, Matplotlib, Seaborn, all that good stuff. It allows you to do all of that right in the window, which is kind of cool. Okay, so that's the copy. Brian Ross, K nearest neighbors. Here it goes. I found it, everyone. Okay. And I'm going to share it right now. So that way you can see what like make school homework looks like. Okay, Brian Ross. Okay, and let me share this. Stop screen sharing, and then share screen. And then here's something that I was just working on and kind of just what it looks like. I'm not going to go too in depth with it. But, okay, Brian Ross, K nearest neighbors. I open it up in Safari because I'm anti-Chrome, I guess. All right. So this is kind of like what a machine learning, this is the very last class of your data visualization and like your first DS class, the very last class. You start to get into some machine learning. I assume next term I'll be taking the full machine learning course, which is kind of exciting, and really getting hot and heavy into it. So this is kind of what it looks like. Of course, it was made by our instructor, Joseph, who used to work at NASA. It's pretty cool. And so you explain what a machine learning model does. And you can go through all this. I think it might be online on GitHub. I'm not entirely sure. And classification and regression are different types of things. And it talks about supervised learning. We have a Pima Indians diabetes data set. And then you can kind of import all your libraries right here, just like this. And then it runs right in a window. And you just run it just like that. Pretty cool Google Colab notebook. And then you can just run another thing just like it sort of looks like a Jupyter notebook, you might be saying to yourself, and I would agree. And then you have our data set. Anyway, you go through all of this. Oh yeah, we have a cool what is this again? A cool heat map. Yeah, correlation matrix. Heat map correlation matrix is kind of what it is. And then pre-process the data, and then we have our X and our Y and yada yada. And then you go through all of this, and we have some math here. We talk about K nearest neighbors, and here's a bunch of code that we had to do, and all of this. And eventually what you get is you get something like this, and we have our prediction. So our best accuracy. So essentially when we run through all of this is kind of like what it really looks like when you run in machine learning. And our best accuracy is 23. If we have 23 neighbors in our data set, if we have one data set and then we get 23 others, that's going to be our most accurate prediction, is kind of aggregating those 23 others. The more you go, the less sort of accurate you get. You kind of go back to 0. So it pops up and then it comes back down, and then we have another data set, and then this is the one I did. This is the one I did. It looks just like that. So as you can see, the more neighbors we have, the more accurate it sort of gets in this instance for our penguins. And in this thing, it was, what were we trying to do? Oh yeah, we were trying to see a correlation between build length, build depth, flipper length, body mass. And now again, kind of technical, because the more I look at this, the more I just kind of want to study it and take another look at it. And of course, all of this I did not know how to do before I joined Make School. All of this now I kind of I understand a bit better, and I'm going to understand even further. And yeah, so I didn't come into this knowing a whole bunch about code. I didn't know any code actually a year ago. So, you know, how about that? And then Palmer Penguin. So all this stuff, very cool, very exciting. You'll see it when you come to Make School and do the data science class. Anyway, I think that's about it for today. Thank you for bearing with me through the beginning with the audio stuff. There's always at least a few audio problems. It's not tech topical unless there's audio problems. So there's the document again for the tutorial. Here is the Tech Topical archives. And follow us on Twitch. join the Discord at MakeSchool, make.s/join-discord, and watch archive, all of that good stuff. I had a good time. I hope that you all enjoyed it as well. And I will see you all next time for another great time of Tech Topical. If you can notice, when the show started, it was light out, and now it's dark out. And now it's getting kind of... I like this lighting, though. I think it makes me look handsome. Not that I need much help. Anyway, all right, I'll see you all next time. All right, bye-bye.